This is Dr. Earl, and this video lecture is on solving trigonometric equations. I have an example that I'm going to go over with you, and this example should help you when you start solving your equations, because you'll have some equations that will be similar to the equation that I'm going over. And this is on page 695, 696. You'll see some of these types of problems. So the problem is as indicated there. Uh, it's problem number 53, and problems 43 through 58. They all work similar to this problem. So as you can see there, the original problem was sine x times 3 sine x minus 1 equals 1. So the first thing I did, I distributed the sine x. When I distributed the sine x, I got sine x 3 sine x squared plus negative sine x equals 1. So I changed that minus to plus or negative. So then I looked at it and I saw that it was quadratic. So I tried to solve it by factoring. So I had to get 0 on the right side of the equation. I added a negative 1 to both sides. That gave me 3 sine square x plus negative 1 sine x plus negative 1 equals 0. I tried to solve it by factoring, but I couldn't do it. So when you can't solve a quadratic by factoring, you use the quadratic formula. So what I have here, though, is sine x squared instead of x squared. And instead of x, I have sine x. So that means sine x is taking the place of x in the quadratic formula. So my a would be 3, my b would be negative 1, and my c would be negative 1. So I plug those into the quadratic formula, and I'm going to get sine x for my answer instead of x. So I substitute everything in, I simplified, and then I got 1 plus or minus the square root of 13 over 6. So that's what sine x is equal to. So now I have to solve it for x. So to solve this for x, you take the inverse sine of both sides of the equation. So that's what I've done here. Inverse sine, they cancel each other. I end up with x on the left side of the equation. On the right side of the equation, I get sine inverse 1 plus or minus the square root of 13 over 6. And then I do this on my calculator. I get inverse sine 0.767529. And when I do 1 minus the square root of 13 over 6, I get inverse sine negative 0.43426. And then I do the inverse sines on my calculator. When I inverse sine this, I get x equals 0.8751. And of course it's plus 2n pi, because the sine is periodic. It just keeps repeating itself. So that's why we add on the 2n pi there. And for the next one, as you can see there, I take the inverse sine on my calculator of a negative 0.43426, and that gives me my angle x equals negative 0.4492 plus 2n pi. So that's what I get there. So those are my two original solutions. So as you can see there, we have x equals 0.8751 plus 2n pi, or x equals negative 0.4492 plus 2n pi. Now, the textbook told us to give the answer in terms of positive angles, and your positive angles have to be between 0 and 360, or between 0 and in 2 pi, because 2 pi is the same as 360. And of course, so that's what we would have. So we have to change this angle here into a positive angle, and we have to see if there's another positive angle here that we could use instead of 0.751. So to do that, we put these angles in the rectangular coordinate system. We put this angle in there, 0.751, and this angle here, negative 0.4492. And when we do that, it looks like this. This is 0, and this is 1.57. That's 90 degrees. 3.14, that would be 180 degrees. 4.71, that would be 270, and of course 0 or 360 would be 6.28 as far as radians are concerned. So 0.8751 would be in the first quadrant because it's between 0 and 1.57. So that angle we already know. We can have 0.87. We can have 0.8751 plus 2 n pi. Now, this angle could be a reference angle to an angle over here, to a large angle. This angle here, you see, it could be a reference angle over here. You see, because the sign is positive, so that means it could be in the first or the second quadrant. So if it's in the second quadrant, this would be the reference angle. So then we just have to figure out how much this big angle here is. So we just subtract 0.8. We have to figure out how much this big angle here is. You see. And this is the reference angle of 0.8751. So we just subtract 0.8751 from 3.14, and that would tell us the size of this large positive angle here. So I've done that here, as you can see, and the difference is 2.2649. So therefore, we get as a solution 2.2649 plus 2n pi. So we do the same thing with the other angle. It was a negative 0.4492, so that would be located here because it goes in the negative direction. But the sign was a negative number. So if the sign was a negative number, it could be in the third quadrant or the fourth quadrant, which means this angle here could be a reference angle for an angle that's over here in the third quadrant. So if it is, the reference angle would be here. The reference angle would be 0.4492. So to figure out how much this angle is here, from here to there, we simply add 0.4492 to 3.14. We add 0.4492. This angle here, we add it to 3.14, and when we do that, we get 3.5892. So therefore, as a solution, we will also have a 3.5892 plus 2n pi. And then to get the big angle here, from here all the way over to there, because it's got to be a positive angle, we simply subtract this from 6.28. Subtract 0.4492 from 6.28. And when we do that, as you can see, I've done that here, we get 5.8308. So therefore, this big angle from here all the way to there will give us a solution of 5.8308 plus 2n pi. So therefore, we really have 4 solutions, which will give us infinite solutions, of course, because of the 2n pi. We have these 2 solutions here that we mentioned, and also we have the 2 solutions that we mentioned above. As I mentioned, you have some other problems like this problem on page 695, 696. Once again, that's problems 43 through 58. So I hope this example is helpful to you when you're working your problems. And you can stop the tape at any time. You can play the tape back. You can play the tape while you're working a problem similar to this problem to see if you get the steps correct. So if you follow that procedure, I believe this will be very helpful to you. Have a great day.